Hello, this is Mr. Huber. In this lesson, we're going to work on solving absolute value equations. If you recall about absolute value, it is the distance that a number is away from zero. So for the example we have in there, absolute value of x equals 9. And let's keep in mind this symbol here, those bars indicate absolute value. Okay. So the solution for this absolute value of x equals 9 would be all the numbers that are a distance of 9 away from 0. So we think about what that might look like on a number line. So we have a number line here. If this is 0, we can go a distance of 9 this way and be at 9. Or we could go a distance of 9 to the left of 0 and be at negative 9. Both those distances are 9 units away from 0. Distance is never going to be negative. So it doesn't matter which way we go from the 0. If we go 9 units, we're a distance of 9 away. So 9 and negative 9 are both solutions for that equation, that absolute value of 9. So we can write that a couple different ways. We see that down below here, right? 9 and negative 9 are answers. We could write as x equals negative 9 comma 9. That means x is both of those numbers. Or if it's the positive and negative value of the same number, we can write plus or minus. Read that as x equals positive or negative 9, or x equals plus or minus 9. Okay? So let's look at what we need to keep in mind for solving these and then an example. We first have to get the absolute value part of the equation by itself. Okay, we do that by isolating it using inverse operations outside of the absolute value. So keep that in mind. The first example we see, it already has just the absolute value by itself, but we're going to see some coming up where we might have to do some steps before we set up two equations. Because how this is going to work is we're going to have two equations we're going to be able to set up. One right here, right? If we have whatever's inside the absolute value, doesn't matter. A, x, and b can be anything, equaling a number, a value c. Then we're going to have ax plus b, whatever that is, equals c, and then we're going to have whatever that was inside the absolute value equaling negative c. Okay, so when c is some value greater than or equal to 0, we can set up these two equations and solve them to get our two different values for x, for the solutions. So if we look at the example we have here, r minus 7, absolute value, equals 9, we're going to set up r minus 7 equals 9, and r minus 7 equals negative 9. Okay, again, just like we saw up here, c and then negative c, 9, negative 9. And now we can solve these two equations by adding 7 to both sides. We'll have r equals 16. Okay, and then we can add 7 to both sides here. That's r equals negative 2. So our solution is r equals negative 2 and r equals 16. Okay, it's both of those values. R could be both of those values. If we check them, we're going to plug them into our original equation. 16 minus 7 is 9, so we'd have the absolute value of 9 equals 9. Okay, which is true. 9 equals 9. That worked. Okay. If we're going to try negative 2, right, so we can plug negative 2 in as well. We have to make sure that works. We're going to absolute value of negative 2 minus 7 equals 9. That's the absolute value of negative 9 equals 9. And absolute value of negative 9 is a positive 9. It's a distance of 9 away from 0. So 9 equals 9, yep, that's true. So we know that both of those solutions worked. So r equals 16 and r equals negative 2. It's not always the positive or negative of the same value. So don't just solve one of them and get 16 and go, oh, it's plus or minus 16. Now, solve both of the equations you're going to set up there, and you'll find out what your two solutions are. Right? Let's pause from solving these right now and talk about a bolt of brilliance. A little clue there. You know, I like alliteration, the bolt and brilliance. I want to find out what's 5 times hotter than the sun. Think about the clue there. Bolt of brilliance. And you may guess a bolt of lightning. That's pretty amazing because the sun is pretty hot. And so you imagine a bolt of lightning being 5 times hotter. That's pretty impressive. All right, let's see a couple more absolute value equations and solving them. So in number 2 here, again, anytime we're going through this, you should pause the video, try a solution yourself, see if you're doing the steps correctly when you're going back to play it. So if you're doing that, that's good, and you should be able to follow and see if your work is accurate, and if not, where you're making some mistakes so we can get those figured out and corrected. Okay, so if we look at this, we're going to add 5 to both sides. This is an example of where we need to isolate the absolute value expression. The absolute value expression is this part of the equation that's inside the absolute value. Okay, we need to isolate that by itself. So we can do that by inverse operations on both sides, like we normally would when we're trying to isolate a variable. Okay, so we add 5 to both sides here, and we'll have 4 absolute value of t plus 9 equals 19 plus 5 is 24. Now we can divide by 4 on both sides, and we'll get absolute value of t plus 9 equals 6. This is where we can set up our two equations. So we're going to set up t plus 9 equals 6, and t plus 9 equals negative 6. Okay, we isolated the absolute value expression. Now we'd set up our two equations. Okay, isolate that absolute value expression first. Then set up the two equations we see here. We can subtract 9 on both sides, and we get t equals negative 3. We subtract 9 on both sides here, and we'll get t equals negative 15. We should do what now? That's right, check our answers back in the original equation. Always go back up to the original equation. We don't want to check in one of our steps because there may be mistakes. So go back up here and plug in for t, okay, negative 3 and negative 15. And so let's see what that might look like. If we plug the negative 3 in, we're going to have 4, absolute value of negative 3 plus 9 minus 5 equals 19. So we'll have 4, negative 3 plus 9 is 6, minus 5 equals 19. So that's 24, because the absolute value of 6 is still a positive 6, minus 5 equals 19. Sorry, that little mistake there. Let's clean that up. All right, 19, and we get 19 equals 19. So that in fact works. 19 does equal 19, and so we plug negative 3 in, and it was a correct solution. If we plug in negative 15, it will also work as well. The negative 15 plus 9 is negative 6. The absolute value of that negative 6 would be a positive 6 times 4, and then minus 5, and we'd see that it works. Okay, but make sure you're checking your answers when you're doing these problems, like you should anytime. All right, on number 3, we're going to subtract 22 on both sides to get 3, absolute value of x plus 7, equals negative 18. And then if we divide both sides by 3, we get absolute value of x plus 7 equals negative 6. And so if we set up our two equations, we're going to get these two to solve. And if we go to solve those by subtracting 7 on both sides, we get x equals negative 13. Subtract 7 on both sides, get x equals negative 1. This is where we should check our answers. Okay, let's check our answers. Let's plug negative 1 in. I'm going to have 3, negative 1 plus 7, absolute value, plus 22 equals 4. I'll have 3 times absolute value of 6 plus 22 equals 4. And I have 18 plus 22 equals 4, and I'm going to get 40 equals 4. This doesn't seem like a good solution. So what may have happened? Did I make a mistake along the way somewhere? Did I plug it in incorrectly? Go back, check your steps. Did we set something up wrong? Did I add or subtract wrong? Right? Where did I make a calculation error? We didn't make any errors along the way. The problem is negative 1's not a solution. Okay? There's no steps in getting to x equals negative 1. Okay, all of this work that we did over here was accurate. All of it. Okay, everything we did, the subtracting 22, the dividing by 3. The problem is right here, where we see x plus 7, absolute value, equals negative 6. It'd be impossible for an absolute value to equal a negative number. There's nothing you can plug in here for x, add 7, and then when you take the absolute value, you end up with a negative, because the absolute value here is always going to be a positive distance from 0. So neither of these are going to be solutions because we ended up with, in this step, something that can never be true. You can never get an absolute value equal to a negative. So there's no solution for this particular problem. No solution. All right, so keep an eye out for that. That's why you want to check answers, because sometimes you can get answers that don't work. You can come up with something that's no solution, and different things that can happen that might throw you off. So make sure you're checking those answers. All right, let's look at one more here. This one has solutions. So again, you should try this one. This will be a good chance to see if you're kind of on the right track with what we're doing here. All right, so if I add 23 to both sides, I'll have absolute value of 3x plus 15 equals 15. And now I've got my absolute value expression by itself. Right? Remember that we want to get this absolute value expression by itself. There's nothing outside of it, adding, subtracting, multiplying. Now this is where I can set up my two equations to solve. So I have 3x plus 15 equals 15. 3x plus 15 equals negative 15. And when I go to solve these, I subtract 15 on both sides. 3x equals 0. That's okay. Don't get scared off by seeing a 0. X equals 0 is okay, and that's an answer. That's a number. We get negative 15 on both sides. 3x equals negative 30. When I divide by 3 on both sides, I get x equals negative 10. Those are my two solutions. Again, I can check those by plugging them in. If I put a 0 in or a negative 10 in, and you should, get used to checking these, seeing that they come out on the left side of your equation, you'll get negative 8 equals, and on the right side a negative 8. In your interest of time, I'm not going to plug those in right now, but you should. You want to see what that looks like, make sure you know how, and that way when you're getting to problems you're doing on your own, you'll know if you're on the right track or not.